Hello everyone, my name is Professor TK the Chemist, and today we're going to go over a video that deals with how do you detect radiation. Okay, so over 20 plus years ago, yours truly, before she was Professor TK the Chemist, she was a student of chemistry. I received this Geiger counter here, and this Geiger counter is very interesting because of what it can actually detect. It can detect radiation. Now, how does it work? I'm going to explain. Radiation is measured in several different ways, and with the Geiger counter, it's basically a tube filled with gas, such as argon. And when radiation enters the window at the end of the tube, it forms a charged particle in gas, which produces an electrical current, okay? And each burst of current is amplified to give a click and a reading on this meter here. Okay, so that's what it is right there. So there's a lot that happens with this Geiger counter right here. Okay, as you can see. Now, I'm not going to demo this, okay? But what I will say is we're going to get into some other components in terms of how radiation is detected. In one of my previous videos, we talked about why you needed to have a radon detector in your basement if you have a basement in your home. Now we're going to discuss how radiation is detected in many other sources. Let's get into it. So the question comes up, and that is, how is radiation measured? Well, when a radiology laboratory obtains a radioisotope, the activity of that sample is measured in terms of the number of nuclear disintegrations per second. Now, the Curie, which is the original unit of activity, it was defined as the number of disintegrations that occurred in 1 second for 1 gram of radium. Remember, Madame Curie and her husband, Pierre, came up with the discovery for radium and polonium. Okay? This was over 120 years ago, by the way. All right. Now, when it comes to measuring the rad is basically radiation absorbed doses in a unit that measures the amount of radiation that's absorbed by a gram of material, such as body tissue. So keep that in mind as well. You know, we get these terms like that deals with chemotherapy and person who's going in to look at their organs if they have some blockage and we want to know what's happening internally. We have to use the different various amounts of radiation to zoom in to that particular part of the body. And then there's what's called the REM, R-E-M, which stands for radiation equivalent in humans. And this is a unit that measures the biological effects of different kinds of radiation. Now, I'm going to put a formula on the screen so you can see exactly how they use these to determine radioactivity that's being beamed within the body. Now, keep this in mind, that although alpha particles are often blocked with a piece of paper, here's the issue. If alpha particles somehow miss that piece of paper and it enters your body, there can be some detrimental effects. The same thing with gamma rays and beta emissions. So, and as you know, alpha particles can cause extensive damage. So when you have high energy particles like beta that emit so much energy, they can travel into tissue and they cause even more damage, okay? So these are some of the things that you all need to be aware of. And gamma rays, as we mentioned before, are damaging because they travel a long way through body tissue, okay? So on your screen is going to be the chemical formula that we will use in order to measure the dosage amounts of radiation. Here it is. So the formula is biological damage, meaning the REM, is equal to the absorbed dose in rad times the factor. And the factor that we're referring to is the factor that adjusts for the biological damage by a particular form of radiation, okay? So stay tuned as we get into more illustrations on how you are exposed to radiation. Can you think of any ways? Give me your top 5. Come back and let me know what your top 5 are in terms of being exposed to radiation.